Hello dear students, welcome back to study physics chapter 3. Uh, we were stopped in the Archimedes principle, and even we studied what was the principle. We said that if you have three container, how's the process? Partially objects comes under the waters, some of the waters comes out. We studied all, and we studied some rules. Today's lesson we have three important question. Then you have rules, and we'll solve some examples about buoyant force. Students, we have an example. It's written, when does an object sink, or when does an object can go under the water? When we know that the object can't go under the water or can sink. Guys, look, imagine this is the surface of the water, and under the surface, of course, you have water, right? This all is water. That one all is water. This is water all. And on the surface of the water, we have, for example, any object. We have an object. This is an object. It's called object. The question said, when this object can go under the water or can sink. When this situation will be happen. When? The answer is written, if an object density greater than the full density. It means that the density of this object, the density of this object, if it's greater than the density of the water or fluid. Another meaning, this object that you have, if it's their mass it's heavy, or their weight is heavier than the weight of the water, then the object can go under the water. The density of the water, because we know if any matter, any substance has more density, that means has more mass, has more weight. So because the object it's heavy, has more density, so the object can't go under the water. So look, if an object density greater than the full density, object density greater than full density or water, in this situation, this object can go under the water. So in this situation now, this object comes under the water. It's still water, so the objects now can come under the water. Why? Because the object density is greater than the density of the water. And it's written in the second part, the net force is negative, downward. Why? What the meaning of net force negative? We studied this rule. We had this rule. F net, the net force, F net, it means a total force equal to buoyant force minus gravity force. Why in this, when the object goes under the water, the net force it will be negative? Because guys, look at this question, look at that picture. As we know that the direction of the buoyant force all time from the upward, and the direction of the gravity force all time from the downward, Fg. Because when the object it's come under the water, it's same direction with the gravity, same direction. So in that case, Fg has more value. Imagine Fg has more value. For example, put any number. The Fv is 3 minus. Fg has more value. For example, has 9 the number. And 3 minus 9 will be negative 6. Look, so the answer by negative. That's why the net force will be negative. Because when this object it comes under the water, it's same direction with the gravity force, because gravity force will sit all time from the downward, and the objects too come under the water, it's same direction. Look, same direction. So in that case, FG has the greatest value. So if it's greatest value, because it's the side it's negative, the last answer, the net force will be negative. So in general, in question, when the object can go under the water or when an object can sink or submerge, when the density of the object is greater than the density of the fluid, or another meaning, the density of this object is greater or has more mass, or the weight it has greatest weight compared to the waters. And that's the first question. The second question, when does now an object floats, it means in which situation the object can stay on the surface. They can stay on the surface. In which condition, in which situation, or when we can say that the object, they can stay on the surface, not under the water, on the surface. Again, let me draw the picture. Again, this is the surface of the water. Under the surface we have a water. Look, it's all it's water. And again, we have an object in here on the surface of the water. We have an example why this object they can't stay on the surface on the water. They can't stay here without going under the water. Why? Because the density of this object, it's smaller than the density of the water. Or another meaning, their mass, the mass of the object, it's not heavy, it's lighter than the mass of the water. Their weight, it's lighter, not heavy. They can stay on the surface. So the density of the object is smaller. For example, imagine, we know that the density of the water all time is 1000. Imagine the density of this object, it's 800. So look, the object it's 800 density, but the water is 1000. So look, the density of the object it's smaller than the density of the water. That's why the object can't stay on the surface. In that case, the net force it's positive, not like the previous question. We said it's negative, but in this case it's positive. Let me tell you why it's positive. Yeah, what was the rule? F net equal to buoyant force minus Fg. And as we mentioned that the direction of the buoyant force all time from the the direction of the gravity force all time from the downward, and the direction of the buoyant force all time from the upward. Because the object it can't stay on the surface, and behind that we studied because the water force can push the object to stay on the surface. So because of the buoyant force, the object can stay on the surface. So in that case, Fb has more value. So Fb sign is positive, has more value. So F net at the end will be positive. So in this case, when the object is on the surface, Fb has greatest value. The net force is positive. But when the object previous question it goes under the water, Fg has more value than the net force is negative. So look, let me tell you by another way. We know that the direction of the gravity from the downwards and the buoyant force from the upward. Buoyant force. Because the object it can stay on the surface of the water because of the force of the water. Buoyant force, they can push the object to move up. So Fb has more value in that case. So at the end, F net is positive. The last question, when does an object suspended under the waters? You know what that means? Again, we have the surface of the water. Again, look, we have the surface of the water. In that case, this is water. The object it's not totally over the surface and is not totally goes under the water. The object they are staying in the middle of the water in here. Look. So in that case, actually we don't know that. We don't know the object it goes sink under the water or the object is on the surface. We don't know. The object they are suspended, they are stuck in the middle of the waters. So in that case, why this happened? Because the density of the object and the density of the water, they are same. Because look, this is the water, and sorry, this is the surface, and this is the water. The object, they are stuck in the middle of the between the surface and between the water. Look in here, they are stuck in here, the object. Why? Because the object density, it's equal to the density of the water. Both of them is 1,000. For example, imagine both of them is 1,000. So we don't know the object is on the surface or the object is under the water totally. We don't know that. So the object, they are staying in the middle of the water. In that case, why this happened? Because both density are equal. This example is important to understand. One thing is left. We have this rule to solve example is important. Students, look. Fg object in air over buoyant force equal the density of it's written O, it means object, density of the object, over rho F, density of the fluid. So the weight of the object in air, buoyant force, equal to density of the object over density of the fluid. The last expression is useful to solve an example. So we have this rule and another rule of the buoyant force. We say that buoyant force is equal to what? Fg object in air minus Fg object in fluid. This lesson just important to memorize this rule, these two rules only. Fv buoyant force is equal to Fg object in air minus Fg object in fluid, and this is the general rules in this lesson. Fg object in air over buoyant force equal to the density of the object over density of the fluid. Let me solve some example now. Okay. This example. We have this golden crown, this one. We have 2 Fg. The Fg, the weight of this gold crown in air, and this golden crown goes under the waters. We have 2 Fg. So first Fg 7 point Fg object in air equal to 7.84 in air. Look, and Fg object in fluid equal to 6.86, or Fg object in the water. Look, the object goes under the water. Well, the question said actually explain, but no. Find the density of the object. Density of this object. How we can find the density of this object? What was the rule? The rule: Fg object in air over buoyant force equal density of the object over density of the fluid. So the question said find the density of the object, that one. Multiply both together. Density of the object times Fv equal to density object times Fv equal Fg air times rho F, Fg rho F. We want to find what? We want to find density of the object, that one. So divide both sides by Fb, because we want to find density of the object. This two ones will be cancelled. So density of the object equal Fg object in air, we have it's 7.84 times density of the fluid, the density because it's in under the water. Look, so density of the water all time is 1,000 over, but there is no buoyant force. But as we mentioned in the previous slide, we have another rule to find buoyant force. I'm going to write in here. Look, buoyant force equal to FG object in air minus FG object in fluid. Okay, equal. FG object in air we know is 50 minus the FG object in water or in fluid is 6.86. 6.86. So now minus it. Minus 50. Sorry, this is not 50. It's 7 point. I thought it's certain 50. No, that one. It's 7.84. Okay, 7.84 minus 7.84 minus 7.84 minus 6.86. The answer is 0.98. 0.98. So we get the value of buoyant force. Immediately put it in here. Look, 0.98. So multiply these two together at the end, divide by 0.98. The answer is 8,000 kilogram per meter cube, the density of the object. So according to this rule, we can get buoyant force and immediately put it in here instead of the FB value, 0.98. We have another example in this book. Okay, a piece of metal weight 50 Newton in air. I'm gonna solve part A first. So FG object in air equal to 50 Newton. Look, 50 Newton in air, it means FG object in air, and 36 Newton in water. The FG object in water or fluid, same, equal to 36 Newton. We have the same object, the same metal in another fluid, 41 Newton in now unknown liquid. We don't know the type of the liquid, but it's certain unknown, that's why. So this is called, we can write like that, FG object in unknown equal to 41 Newton. Okay, find the density of the following. First, find the density of the metal. Metal object, it means find the density of the objects. Okay, same rule. Same rule. What was the rule? FG object in air over buoyant force equal to density of the object over density of the fluid. The rule, same rule. Yeah. Sorry, wait. Multiply now. Density object with FB, it will be density object FB equal FG air times rho F, FG air times rho F. We want to find the density of the object, right? So how to find the density of the object? Divide both sides by buoyant force. The buoyant force is going to be cancelled. So density object is equal to FG object in air. Look, we have it's 50 Newton times the density of the fluid, guys. Again, because look, we have a water. So the density of the water, we say all time is 1000 over buoyant force. Again, there is no buoyant force. I'm going to find the buoyant force in here. The rule of buoyant force. We know that the rule of buoyant force equal to FG object in air minus FG object in fluid. Equal. FG object in here we have is 50 minus FG object in fluid we have, look, 36. So 50 minus 36, the answer is 14. So we found the value of buoyant force. It's 14. So instead of the buoyant force, because we found it, is 14. Look, in that rule, FG object in air minus FG object in fluid. So in air we have 15 minus in food or water, same 36. So 15 minus 36, 14. So instead of the value of buoyant force, write 14. Finish now. Just multiply 50 by 1000 and at the end divide by 40. Use calculator. 50 times 1000 and at the end divide by 40. So the answer density of the object is equal to 3571 kilogram per meter cube. The answer of part B. The answer of part A. Part B. Part B is left. Now find the density of unknown liquid. Unknown liquid. Let me erase it. Hold on. Good. Yalla, part B. Find the unknown liquid. So guys, the density of the unknown liquid. Liquid, it means fluid. يعني find the density of the fluid now. Okay. Same rule. Fg object in air over this part B. Buoyant force equal to the density of an object over density of the fluid. So guys, the part B said what? Find the density of the unknown liquid. يعني find density of the fluid. يعني you have to find density fluid. Same step, multiply together both. Density object times FB. FB rho not equal Fg air times rho F. Fg air rho F. Okay. So we want to find the density of the unknown liquid. It means rho F. So how we can find rho F? Divide both sides by Fg air. Divide both sides by Fg air. The Fg air, Fg L gonna be cancelled. So rho F equal to what? Equal to this equation. Fb density object over Fg in air. Okay. Yalla. Fg object in air again we have is 50. Density of the object, guys, in that case, because the previous part 8 already we found it. We found the density of the object, it was 3571, right? Part A now we did. So instead of the density object, write this number because we found it. 3571 times. What about buoyant force? We don't have buoyant force. Again, but we have rule to find it. Buoyant force equal to the weight Fg object in air is 50 minus. Guys, but let me write the question first to understand easily. The rule, it was what? Fg object in air minus Fg object in fluid. But in this case, because you have to find the density of the unknown liquid. So in here, we have to minus by the weight of the unknown liquid. يعني Fg object in air minus Fg object in unknown liquid. Because why, mister, we didn't minus by Fg, the weight of the water? Why in unknown liquid? Papa, because part B it said find the unknown liquid. We are showing part B is unknown liquid. That's why you have to minus by the Fg of the unknown liquid. Okay. So Fg object in air again 50 minus the Fg object in unknown liquid. Look, this one is 41, huh? Fg object in unknown liquid 41. So minus 41. So 50 minus 41, 9. So Fb buoyant force, it's 9 Newton. So put it in here. Instead of the Fb, it's 9. So done. Guys, so P naught, the density we did in part A. Do not say, Mr. where this number is coming, 3571. It's part A answered. We found density of the object. And where the point for it's coming, we have this rule. FG object in air minus FG object in fluid, but because we are solving part B, it's unknown liquid, so minus by the unknown liquid. 15 minus 41, 9 it's left. So put the FB in here. And we have FG object in there, it's 15. So multiply the answer, let me check the answer. 3571 times 9 and divide by 50. The answer is 642.78. The density of the unknown liquid is equal to 64. Here there's no space. Wait a minute. Let me write in here. The answer, density of the fluid, equal to 642.70. There's no place. That's why you cannot write it. Wait a minute. The answer eraser. The answer is density of the object 642.78. The answer is 642.78 kilogram per meter cube. The answer of the density of the unknown liquid. Guys, today's lesson is enough. We solved 2 examples. Inshallah, from the upcoming video, I'm gonna solve the examples that are left for you. Thank you for watching my channels. I have to get the benefits from my video, physics grade 10 system, English system. Thank you for all. If there's any question, you can write down in the comments. Thank you for all again, and have a nice day.